Okay, so for lab 1 and 3, it's pretty much what we do about circuits. This we do the resistors. We use resistor and how to measure the resistance, and how to use voltmeters, how to use ammeters, how to use voltmeters. So I will just start with that, like this, in terms of how many knowledge points that we're going to go through. So first, signs. We have pedestrians. No, not pedestrian signs. The resistor. So in real life, I will try my best, but it won't look pretty. But something like this. It's like a cylinder. It's a resistor. And we have DC power supply. DC also can be written in the sign of this. That means DC. And in real life, it will look something like a box. And that will be positive. Red is positive. Blue is negative. Or you have your dry battery. Also dry battery. Dry battery is DC as well. So this is positive. That is negative. So also we have AC power supply. Just it's almost look like the same, but dry battery is not AC. AC looks like this. AC and DC, that is only DC. Dry battery. AC, the sign will looks like this. That's the sign for AC power supply. And we have our capacitor, like two parallel line. And in real life, it looks like either a cylinder or looks like this, or look like a cylinder. And also we have voltmeter. Oh, by the way, feel free to ask any questions, because most of the time I will facing the chalkboard, so just yell, Max, have questions or stop. That will get my attention. So in real life, it will look like this. So it will point at this. So make the circle smaller. So it will look like this. It will point at this, and it's in the blue, red. See, like there's like blue and red. So you connect to the middle and the right. That's the voltmeter. And then we have our ammeter. I may have typos, please point it out. I mean, vitals. The sign, you should point at the sign like this. Keep in mind, this time you should connect to the left and the middle. So I'm out of chalkboard space. Is that okay that you read this part? Okay. So we have our ohmmeter. I don't know if that is a legitimate sign, but let's just go with it. Ohm meter. And what it looks like in real life will be like this. Here, ohm. So thus you should connect the middle and the right. Okay. And just for the completeness, if you want to measure the capacitance, I don't know if that's the correct sign though. Capacitance meter. I don't know how to have a short name of it. But anyway, you should put it here, which have this kind of sign, and you should connect to the middle and the right. And after turning to that part, you need to press the yellow button. The yellow button here to switch it to capacitance meter. Otherwise you will measure the dial, the mode of dial. So yeah, that's the sign. So far, any questions? I mean, I will post this video online, so don't get too worried about the. Yeah, it's recording, so don't worry about missing any note. Cool with? You guys cool with it?
Yes.
Okay. The next knowledge point is, of course, Ohm's law. Oh, number 2. Number 2. We have R equals V over I. It's kind of normal, but it means a lot. That's the Ohm's law here. And then we need to know about the equivalent resistance of a parallel and series. For equivalent of series is R1 plus R2. So the series looks like this. R1, R2. Right? And equivalent of parallel is R1, R2 over R1 plus R2. And the parallels looks like this. Okay, just draw a line to make it distinct. Right. So the equivalent means like you can take the whole thing as one resistor. The resistance of that whole thing will be R1 plus R2. For that will be R1, R2 over R1 plus R2. That's the third knowledge point. The fourth knowledge point is how to use DMM, the digital multimeter DMM, yes. So we already know how to connect it. How to change it to the mode of DC ammeter, DC voltmeter, ohms, voltmeters. We need to know how to measure the voltage and current for the sake of practical. So the way to connect an ammeter is like this. Just make it in series of the resistor. The tricks I talked about are just think this as a if previously we have a resistor and a wire. Just replace that wire with an ammeter. And then the way to connect a voltmeter is just in parallel of the resistor or the component. You can then measure if the resistor have two ends, right? Have two ends. You can just connect each end with the cable come out of the multimeter. And also if you want to measure the resistance, you just simply connect the resistor with the ohm meter. Just resistor and the two end with the two end of the resistor connect the two ends with the ohm meter. So let's practice a little bit on how to connect, based on the schematics, to connect a real life circuit. So as I mentioned before, on the left one, we can try to draw a real life one and then use that to connect it accordingly. Once there's so many repetitions, you will find you don't actually need to draw a real life diagram. So, but for now, let's draw one. So here is our battery. Positive, negative, and here is our resistor, and here is our multimeter. DC voltage. Connect the middle and the right. The two ends of the resistor connect to the two ends of the voltmeter, and the both ends of the resistor go back to the battery, like that. You can the good old trick we talked about is just trace the wire to the capacitor to add each component of the schematic. And there we go. That's how we connect it. And for ammeters, the way you want to change it is just change this to ammeter. Change the wire. Don't forget to change the wire to the left and middle. And as you read this, and you want to essentially replace this wire with ammeter, right? So like this. So you want to basically in the real diagram you want to replace this wire with. So basically, if you erase this, you connect both ends. Close the loop by connecting, connect those two open ends to those two wires, like that. Bless you. And there we go. That's how we measure the current. So yeah, I suppose in the practical, that's how because I don't think there's anything gonna go out of the scope for circuit practical. That's pretty much it. Yeah. Any questions? No. I will erase this. Then the lab 2 is RC circuit, and it introduce a time constant, and also introduce concept of capacitor, and the equivalent capacitance in parallel and in series. That's pretty much the whole scheme of what we're gonna do. And I get more of this. Yeah. Okay, here we go. So lab 2. So we have I need to try to remember this RC circuit. It's charging. Remember, in the lab we do charging and discharge, and using the computer to see the V versus T, or T versus V, V versus T. You have something like this, charging, and then we change the switch. Effectively, we change the circuit to this. Basically, just capacitor and resistor. So we have our discharge plot, which is the key concept point. Looks like this. The discharge formula is V equals to V equals V naught e to the negative t over tau, where tau is R dot C, resistance times capacitance. It's called time constant. It's basically measured how fast it discharge. Basically, how long, what time it takes to change from V to V naught over E. It takes time tau, which is time constant. Yes. Yeah. That is this concept of time constant. And you can plug in any time into here, and then you can get what voltage you will get out of that by knowing the time constant and time. Time constant you can calculate by knowing the resistance and capacitance. So that's our RC circuit. At least that's what we need to know for this class, I guess. Then we have two more knowledge points, I think. Capacitance. Definition of capacitance. C equals to Q over V. Wait, is that lab 2 or lab 4? Can someone check that now? Is lab 4?
I think it's 4, the RC circuits.
Okay. Well, there's no turning back. Lab 4 then. So here's a definition of capacitance, the charge versus voltage. So you can just think the capacitance is literally what it sounds like. So how much charge it can hold for a given voltage. You can use this formula for knowing I guess if they give you the voltage, you know how much charge you have this time, I guess, from using those two formulas. And number 3, we have equivalent resistance C1, C2 over C1 plus C2. That's a parallel, which is exactly the opposite of. Oh, sorry, that's a series. That's a series. I'm so sorry. That's a series. Exact opposite of what we had on the resistor. And the parallel of the capacitor is